In this second video of session 2, I'm going to show you how to use the function explore and how you can use explore in order to examine certain variables according to certain categories and how to test for normality. The function explore can be found under analyze, descriptive, and here we see the third element we haven't used yet is explore. If we click on explore, a new window opens that looks pretty familiar. On the left hand side we have all the variables of our data set, and on the right hand side we have the empty windows where we select the variables into it. Explore is very similar than descriptives. Explore is basically getting to know your continuous variables, and in our example let's use systolic blood pressure of month 1. We'd like to know that variable a little bit better. We select in the depend list window, but in addition to descriptives, explore can give you graphs as well, and explore can help you to find out whether your continuous variable follows a normal distribution. Knowing whether a continuous variable follows a normal distribution is very important, because many statistical tests they require that the continuous variable is normally distributed. It's one of the main assumptions. For some tests we have non-parametric tests. These are tests for not normally distributed data. We're going to learn later on when we talk about the t-test or ANOVA tests what are the non-parametric tests that correspond to the parametric test or to the continuous or normally distributed variable tests. Once you have selected systolic blood pressure, we can go into statistics, and on the statistics you can select, if you're interested, outliners, percentiles. You can also change the confidence interval for the mean from 95 to 90 or 90. We click on continuous. Under plots, we'll find actual normality tests. First of all, we can ask for box plots. We are not interested in box plots. Basically, we can click on none. If you are, you can leave it selected. On descriptives, you can have histograms. Let's have a histogram here, and let's unselect them and leave. Whatever descriptives or plots you like to choose, you can select them. If you like to get to know what information you get out of explore, you can select each of them, and then you see what you actually end up with. Now the normality tests in SPSS are found under explore, under plots, and here under normality plots with tests. Once you select that one, the little box in normality plots with tests, this gives you the two tests we can test for normality, that are the Shapiro-Wilkinson test and the Kolmogorov-Smirnov test. The null hypothesis of the normality tests are that the variable follows a normal distribution. That means if the p-value is below 0.05, we reject the null hypothesis, meaning that the variable does not follow a normal distribution. I'm going to mention you this again once when we get the information and the results of our analysis. Select normality plots with tests in order to get the normality tests. Click on continue, and then basically on display, if you're only interested in statistics and without graphs and normality tests, you could select statistics. If you don't like to see plots, you can select plots. I suggest you to use both as you get more information out of it. You click on OK, and the new window opens on the output window with the big title called Explore. What can we see in this window? What does Explore actually give us? It gives us much more information than only descriptive for the continuous variable. First of all, the first table is a case processing summary. It tells you that the variable selected is systolic blood pressure month 1. We have 60 valid observations. We have 0 observations are missing. Gives us a total of n of 60 and 100%. You can scroll a little bit down and we see the main table of descriptives. Here we can find all the information about our continuous variable. We have the mean value of systolic blood pressure 133.83. We see the confidence interval is 131 100.76 and the upper bound is 135.991. We have the median, we have the variance, it gives us the standard deviation, the minimal, the maximum, the range, interquartile range. It gives you information on the distribution curve. Skewness and kurtosis are indicators of how our variable is distributed, more or less. The important thing is here under descriptors we have the test of normality. We receive two test results. We receive from the Kolmogorov-Smirnov test the results and from the Shapiro-Wilkinson test. Both tests gives us a statistics, a degree of freedom, and a significance. The significance is the p-value. In SPSS, it will never tell you p-value, but it tells you sig. So sig is p-value for the variables you selected. As we can see, the Kolmogorov-Smirnov p-value is different than the Shapiro-Wilkinson p-value. So which test to use? Well, generally for small sample sizes less than 50, we would use the Shapiro-Wilkinson test. For sample sizes bigger than 50, we use the Kolmogorov-Smirnov test. Our sample size is bigger than 50. This is why I suggest you to use the Kolmogorov-Smirnov test, as the Shapiro-Wilkinson test will be less accurate. Remember we said that if the null hypothesis is the variable systolic blood pressure is normally distributed, and if the p-value is below 0.05, we would reject the null hypothesis. In our case, the p-value for the Kolmogorov-Smirnov test is 0.02, which is lower than 0.05. This means we reject the null hypothesis and we declare that the continuous variable systolic blood pressure is not normally distributed. This will have implications for the way how we're going to analyze the data once we come to t-tests, ANOVA tests, and linear regression models. What else do we find here? We can find here the histogram we've selected. This is how the values are distributed, our 60 dwarfs. We have here the blood pressure value on the bottom on the y-axis. On the x-axis we can see the frequency. So we can see how many dwarfs have a certain blood pressure. For instance, a blood pressure of 130 was found by 11 dwarfs. A blood pressure of 120 by 2 dwarfs. It gives you as well some information how many observations we had, what's the mean value, and what's the standard deviation of the systolic blood pressure of month 1. If you scroll down, you can find more information on distribution curves, a normal plot of systolic blood pressure, D-trend normal plot. This is all not really relevant at this stage of the course. If you're interested, you can find tutorials on Google that can explain in details what the additional figures are. However, for our purposes, it's really not relevant. Good. There's another function, another help you can do with Explorer. So let's first of all close that window, and you can save the data or you can continue. In my case, I won't save the data. I go back to Analyze, Descriptive Statistics, and Explore. Before I continue, I put Reset, as I like to select a different variable. Let's select now the variable Education as a dependent list. That's the variable of choice. And now, as you can see, we have a window called Factor List. Factor List is something similar than split file. However, it analyzed the entire data set, but they're going to compare you according to categorical variables, the continuous variable. For instance, we'd like to know education according to back pain of our dwarfs. So we select back pain to the factor list. We leave everything as it is. We select normality test with plots. I unselect box plot. I prefer histograms and unselect stem and leaf. Click on OK and run the analysis. A new window opens, and as you see now, we have here a case processing summary for back pain, education according to back pain. So we have for education, we have 32 people have back pain, have no back pain, 28 people have back pain, the case processing summary. The important information, however, is found here on descriptives. Now you can see that the continuous variable education is presented according to back pain. First, we have the years of education for the dwarfs that do not have back pain, and here we have the information of the variable education for those who have back pain. What can we see? We can see that the average length of education for those without back pain was 8.86 years. For those with back pain was 8.196 years. That is 0.7 years less than with those without back pain. So this doesn't give us any p-value. We will not know if this difference is statistically significant. In order to know if it's statistically significant, we need to run certain statistical tests we're going to do in session 3, 4, and 5. In our case, this just tells us maybe it's hypothesis generating. We could maybe make a study hypothesis or a research question that maybe education is different for the dwarfs without and for those with back pain. So we get all the information of the variables for those without back pain of the variable education, and we got the same for those with back pain. If we scroll down, we have again the normality tests. Now we have, as education is now sort of split for those without back pain and with back pain, we get the p-values. So if we're considering if education is normally distributed among the dwarfs without back pain, we get a p-value of 0.147 that is bigger than 0.05. So we accept the null hypothesis and would say yes, education is normally distributed among the dwarfs without back pain. However, among the dwarfs with back pain, the p-value is 0.028. This means we reject the null hypothesis and we will claim that for the dwarfs with back pain, education is not normally distributed. If you scroll down, you find the histograms for the dwarfs without back pain for education and for the dwarfs with back pain. So this is the additional function get by explore. You can explore a continuous variable according to a categorical variable. It can have as many categories as you want. Important is that you select the continuous variable is the main descriptive variables, factor list is basic categorical variable, and that you can find normality tests on explore for each of the continuous variable. In the exercise of today, you're going to ask to check all your variables for descriptives, for frequencies, and that you check each continuous variables for normality. Categorical variables do not follow normal distributions, and categorical variables do not have to be tested for normality. So only test your continuous variables for normality. Thank you very much, and see you soon in session 3.